In this video we're going to discuss solving exponential equations using logarithms and also talk about how we can check our answer. Now this first one, 5 to the x equals 12, is a basic example of an exponential equation. And just to show you how we could do it real quick with a graphing calculator, then we'll talk about how we can use that to check. What we would do is we'd put in 5 to the x as a graph, we'd put in 12 as a graph, and now we do need to set up our window, because if I do in a standard window, well, I'll see my exponential piece, but I won't see 12 because it only goes up to 10. So let's move my y max up to 15, and I'll see that I'll have an intersection of the two, and where they intersect is going to be where my solution is. So I would just do second, calculate, intersect, and then enter, 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 and I get a solution of about, let's record this, 1.54396. Okay, now that is not an exact answer. Let's say what we're doing, we need more accuracy. So let's talk about finding an exact answer. I'm going to talk about this exponential equation, two different ways to think about solving it. One is we can rewrite it using definition of logs. So the definition of log says if we have a to the x equals y, actually let's use b here, we typically use b for base, then we have log base b of y gives us the exponent. So this would be one way of approaching this problem. We can rewrite it. We got a base of 5, so it'll be a log base 5. We're taking that of 12 because we want to get x. So log base 5 of 12 gives us x. That's the exact answer. Now, we do not have a log base 5 button in our calculator, so we have to use what's called the change of base formula, which we could do as log of 12 over log of 5. Now these could be any logs. We could actually do this as ln of 12 over ln of 5. As long as these logs have the same base, this is always going to be true. And the nice way to remember it is, the base is already lower, so that's what goes on bottom. It's the number that goes on top. So that's one way of thinking about solving this. Another way that's commonly taught is taking the log of both sides. So we have 5 to the x equals 12, and what we're going to do is we're going to take the log of both sides. Because logarithms are one-to-one, we can do this. Now I have a property of exponents that says I can pull the x out front, so I get x times log of 5 equals log of 12, and the last thing I have to do to solve for x, divide both sides by log of 5. So those cancel, and I get x equals, again, the exact answer, log of 12 over log of 5. Once again, when I took the log of both sides, I could have used natural log just as easily and gotten the same thing. Now I said we'd use that number to verify when we checked with our graph. So log of 12 divided by log of 5, and we get the same thing, 1.543959311. So we've even checked our answer. So your graphing calculator is a great way to check your answers, but we need to use logs if we want the exact answer, because this here, while it's pretty accurate, it's not exact, and that can make a big difference if we need to use this answer in another problem. Come and check a couple other videos. I'm going to do some more complicated examples of exponential equations, and we won't spend as much time with the graphing calculator method.